Well, thank you, everyone, ladies, gentlemen, beings of all shapes and sizes. Welcome to Space Apps Brookhaven 2025. This is our presentation and judging awards ceremony. So congratulations, welcome. Welcome all of you. Yeah, give yourself a round of applause. I want to thank everyone for coming out and contributing your weekend to this really amazing project, this incredible effort put forth by NASA and by its partner space agencies. This is truly a global effort, an international cadre of people. Almost 400,000 people since 2012 have participated in Space Apps. You are now part of that global community, so welcome. Welcome to that community. You are working to solve problems to improve life for all humanity on Earth and in space. It's a very important thing that you're doing. Working with NASA, with the space agency partners on open data, trying to come up with new and novel solutions to problems that we all face collectively as a species, as a planet. So again, like you guys make it happen. You know, you are the reason why we're here. You're the reason why things like this move forward. Your contributions, your participation is incredible. Like as citizen scientists, as people who are dedicated, you know, you are the people who are the ones that move things forward. So thank you. That's the first thing I want to say. We have 5 awesome presentations we're going to see today. I should introduce myself, actually, before I get into that. So my name is Michael Caprio. I've actually been a part of Space Apps since 2012. This is my 7th Space Apps organized event. I did 5 in New York City, and this is our 2nd year, actually, here in Brookhaven. You know, I came to Space Apps. I'm not a space person. I'm an enthusiast. I happen to be a software engineer, but you know, I saw this fantastic opportunity. I was managing events, I was making hackathons in the city, and I saw, wait, NASA? Heck yeah, I want to work on a hackathon with NASA. And it just spiraled from there. You know, it opened up a lot of doors for me. I was able to work with thousands of people from all over the region who all became a part of our community. We got to work directly with people from NASA who saw some of our projects, who won global judging. And you know, it's incredible, really, to like be a part of that, even if it's just at a small level. But one thing people may not realize is it takes a huge crowd of people to make these things happen. These are the hardest problems. Working in space are the most difficult technical engineering challenges that are possible. It's the harshest environment, and we have to do incredible things. And it takes really large groups of people to make that happen. And the same is true with the Space Apps Challenge. I want to give some thanks to some of our event partners. So this is Tesla Science Center at Wardenclyffe, is the organization that hosts Space Apps Brookhaven. Tesla Science Center is Nikola Tesla's last remaining laboratory on Earth. Pretty much all the rest of them burned down, including this one, and we are working to restore it and turn it into a global science center. As part of that, we started the space science program. People may not realize this, but Nikola Tesla, in addition to bringing us pretty much every modern technological advancement that we enjoy today, was also a pioneer in space. At age 17, while he was out in the wilderness avoiding military conscription, he envisioned an orbital ring being built around the Earth and a space elevator that could be ridden to hang out on the ring while the Earth turned below and be able to travel across the face of the Earth that way just by going back down to the point of choice. He also dreamed of flight his entire life. He tried as a child to make different flying contraptions, which of course did not work. And his inspiration for the AC induction motor actually came from reciting passages from Faust, which he had memorized, and imagining the sun orbiting around the Earth and sort of spinning around it, you know, and the flying of Mephistopheles and Faust around the Earth gave him this idea for a spinning induction motor, and his vision, his epiphany brought that to be. So, you know, he discovered so many things that we use to explore space. You know, he was probably the first radio astronomer when he did his experiments in Colorado Springs. He built the first robotic remote control drone, which he sailed right off the waters here in Long Island Sound off of Sound Beach. Today, we go from the shores of Sound Beach to the dunes of Mars, where we control robotic rovers remotely using radio, which of course he invented as well. So it's wonderful that we can take, I think, the spirit of Nikola Tesla, who himself was a great humanist, and bring it forward today to the Space Apps Challenge. And really, you know, the same types of principles, the same types of innovations, we're basically tying that all together with Tesla's work. So I want to also thank Zebra Technologies. We are here at the Zebra Atrium for our second year. They very graciously give us the use of the space and have catering that we enjoy for the weekend. We also want to give thanks to Suffolk County Community College, who were a fantastic partner with us this year, helping us to host at their venue our Space Hack Bootcamp workshops, where we taught on the topics of radio, on astrovisualization using the NASA-funded open space scientific visualization software, learning about data and learning about coding. Really fantastic partnership with them as well. And last but not least, I also want to thank US Space Force. Space Force has been an excellent partner for us as well, both at our Nikola Tesla Expo this year, which was a record-breaking event, but also supporting us in educational material and providing swag for our hackers. So without too much further ado, I would actually like to now introduce our judges. So we have three very distinguished folks with us here today. We actually have two scientists from Brookhaven National Labs. We have Paul O'Connor, who's an instrumentation technician. Paul, thank you. We have Justine Haupt, who's also in instrumentation, also a scientist at Brookhaven. And we have Ray Schwetz. Ray is a AVP at Jovia Credit Union. All right, so let's just get right to it. Our first team is Space 2025. Space 2025, come right up, and we will get your presentation loaded.
First slide's up. Hello, my name's Bob Olness, and I just called Space 2025, just kind of came out of my head that way, so. Same one. I'm going to be talking about commercializing low Earth orbit. The nickname is LEO, low Earth orbit. LEO is an altitude of 200 to 2,000 kilometers. So that's about the lowest orbit you're going to be. Anything below that, and you'll probably end up falling down, hitting the Earth. Okay. Okay, next slide, slide 2. Okay, LEO challenge and goals. Basically, let's make LEO affordable. That is low Earth orbit affordable and accessible for research and production. Microgravity is essentially reduced gravity, and compounds and elements in production, things change at that gravity. They're able to get pure products and different structures that, or I should say, some are easier or cheaper to manufacture at microgravity. So the whole purpose of LEO is to provide accessibility and affordability to government and to research, as well as production facilities to work in microgravity facilities. Of course, there's a lot of expense in that, and that's where profit sharing comes in. In addition to NASA, a lot of commercial endeavors have worked on space satellites, telephone, as well as commercial satellites. LEO is the closest orbital path to Earth offering excellent opportunities for satellite imaging, communication, and spaceflight. Slide 3. So who would be interested in LEO? Well, of course, space defense, information technologies. We have lots of communication satellites up there. Medicine, power, green technologies. Let me mention climate change initiatives, because they take pictures and they can know in advance, oh, there's a drought here, not so much water, trees are dying. Obviously, or that's a space where they might expect forest fires to be accumulating, or people in need of water for agriculture or whatever. But having a series of pictures over time gives them, allows them to predict future events that could affect climate change. So just some of the things that happen that people on Earth gain by having access to LEO. Slide 4. What are the benefits of LEO? I mentioned microgravity, also facilities for astronomy and space exploration. Obviously, at the altitude, you don't have to worry about clouds, you don't have to worry about the pollution in the air, much clearer vision, less distortion from the air or atmosphere. It's a base for expanding missions to Mars and other interstellar missions. And of course, the very popular task of space tourism. Slide 5. How do you get to LEO? Traditionally, it's a rocket, but it's what they have dedicated launch and rideshare. Dedicated is when the military or NASA has a launch and everything on that rocket is their property or their experiment. Rideshare is more for the commercial. So that's where they have a size and a weight, and people say how much their item weighs or how big it is, and then they take multiple person or commercial entities and they combine all those weights, put them on one rocket. And that's where LEO really takes place, because you have multiple people. So in having to send up one rocket with a small item or a couple of items, they can maximize the weight and the size available on that rocket, thereby decreasing the cost per item for the commercial entity. And that's where LEO really takes advantage by reducing the costs and improving the efficiency. Future developments for LEO is very important because rockets are expensive. And air launch is where you take a plane up to high altitude and launch a rocket from that altitude. It could be anywhere from 10 miles up. Kinetic launch is where this is scientific. They use a centrifuge to spin something around and shoot it into the atmosphere. They've also done catapults and rail guns and other types of trajectories, but a lot of difficulties there. It's still technology, it's still on the drawing board. Nothing has actually been built. The last is orbital transfer vehicle. That's a space shuttle. That's really what it is. Slide 6. Now we get down to the meat. Cost for LEO. LEO's not cheap. The private mission cost for 1 kilogram is about $20,000. So a lot of kilograms. And the cost for a man hour in space is approximately, this private venture, approximately $130,000 per hour. So that's expensive. When you consider the price of gold is right now $125,000 a kilogram. So add up the gold bars you have to put every hour you have someone in space. But that's where LEO's partnership comes in. And by sharing that cost among multiple entities, working on partnerships to keep expenses low, and also in the future, working on development of technologies to reduce the cost of transport to that facility is the purpose of LEO. Slide 7. Now, LEO is not without risks. As you know, all the things we have flying around the atmosphere, a lot of junk up there. And that junk is dangerous. And not because of the size, but because of the speed. A lot of the junk up there, it's traveling at over 10,000 kilometers an hour. And it can be only the size of a screw or something, but it has so much energy, mass equals mc squared, you know that. So the energy from that single screw can devastate a space station or something. And for that purpose, it's a danger. And if we expand LEO and space programs to get to LEO, we're going to have a lot more spaceships. And the concern is, will those spaceships be putting out junk? So that's where we really need regulation, an agreement, as we do for pollution. We need the same for space, so that they build craft that don't pollute and don't add to the junk in our atmosphere. I'm about 8 minutes, so I'm going to, at this point, ask any questions, and thank you for your time. Any questions?
Hello. Just was wondering if you could give an example of some of the, so I have some ideas what the partnerships would be, but what do you imagine some of the partnerships being to revenue share that?
Right now, facilities would probably be the biggest. That is building things in space. Aerogel is one that I was very interested in because it doesn't absorb energy, and so it can be used as a heat shield. And it's very light, incredibly light, cheap to make. But what they need is the zero gravity provides a manufacturing facility that they don't, how should I say, it's different than here on Earth. And they need that uniformity in order to the product needs the uniformity to be efficient. I'm not a techie on that side, but that's one of them. Of course, the predicting climate issues, as I said, forest fires, where there are droughts, hurricanes, we track them, especially here on the East Coast all the time. Medical, they use that currently. Again, it's expensive things, so they try to do as much as they can here on Earth. But if they could reduce the costs in space, it'd be more efficient to do some things. What they are, I couldn't tell you. I'm not a doctor. Again, it's the biggest advantage we have is offering people the opportunity to do things in a different way. And the advantages really come down to the specialty. So whether you're engineer, whether you're manufacturer, whether you're a doctor, whether you're a health person or something, it's really up to you to find the way or consider alternative methods that might work that don't work here necessarily in a gravity base.
Thank you. I have one more question, but I don't want to hog the mic. I also think that there's an opportunity here for job creation, which
Yes.
would also then reduce the cost. Could you talk a little bit about what you imagine that to look like?
Job creation, yes, but the biggest part would be the cost. Obviously, they're going to automate as much as possible simply because to reduce cost. Right now, with the Blue Origin and everything, they're reusing the rockets. So, I mean, they're not building rockets, but still they need technicians and everybody. If they had more facilities, then they need more rockets, and yes, then you'd have more jobs. It's, I want to say, scalable in the sense that if you need more products, you'll have more jobs. But that all comes down to cost, because who can afford at $20,000 a kilogram, who can afford that? So does that answer your question?
That definitely does. Thank you.
Yeah, thanks for the presentation. I have a question too about some of the trends in LEO. So we're seeing these mega constellations getting proposed and even launched, Starlink being the one that's getting a lot of the press, but there are others, both commercial entities in the US and in other countries. In addition to the problems that these may create with just traffic jams, right, avoiding hazardous encounters between satellites, it's a real mess for ground-based astronomy. We didn't anticipate the amount of, it's basically going to be like another form of light pollution. You can't escape it though by going to a high mountain because the satellites are there, they're wherever you go. Can you imagine a way to create a regulatory structure that somehow allows ground-based astronomy to continue to flourish? I mean, without putting the kibosh on on the satellite producers and the commercial side?
Yes. The question was how to clean up the space junk. And they've come up with numerous things, but when you ship stuff up to space because of the cost, you want to keep it as low as possible. So you love to send up, steel plates or something that collect the junk, but that's going to be expensive. What they've been doing is using sails with Kevlar. Now, that will not stop the junk. The junk's moving so fast, it'll go right through it, but it'll slow it down enough, they hope, that it'll lose its orbit and enter the atmosphere and burn up.
I see.
And so far, that's about the cheapest way they have of getting it.
Deorbiting. Yeah, thank you.
It's not clear to me what you're presenting that's novel. Can you tell me what the novelty is here?
One more time?
What is new here? Tell me what the novel
the
idea
users?
is. No, you're presenting a novel idea of some kind, I imagine, but it's not clear to me what it is, honestly.
What LEO is? You want me to explain what LEO is?
No.
What's new what I'm saying?
Yes. To be honest, everything you said sounded like an introduction, and then it just stopped.
Basically, try to identify as many users as possible, because the bigger base you have for users, the more money you will accumulate to build the LEO system. And it comes down to money. There are companies out there that would love to do more facility in space, but the cost involved. And I say it's very expensive to ship rockets up. So if there's a way to reduce that, and right now it's just a matter of getting enough people together to assist with the cost, but in the future it's leveraging the technology to reduce the cost of transport to a space facility.
Okay, thank you.
Did I answer your question?
You did.
Thank you. Any other questions? From the crowd? Back to you.
Okay, our next team presenting is Those Who Know on the challenge for the biology knowledge engine.
Hello, everyone. Today, I'm excited to share a project titled From Cells to Space, Categorizing Biomedical Research. I'm Arav Segal, the project lead and team captain. Joining me are my colleagues Olaf Tur, our visualization specialist, Jaden Bowie, our programming specialist, and Samuel Reyna, our research coordinator. Together, we took on a big challenge from NASA and used AI coding and science to bring clarity to complex research data. I would now like to welcome Sam, who will be discussing the challenge we chose from NASA.
I'd like to introduce a challenge that we chose from NASA was to build a space biology knowledge engine. NASA provided us with 608 biomedical space studies, research studies, and we had less than 48 hours to organize them in a way that would highlight potential trends, patterns, or gaps. And the goal was to make the data accessible and insightful, not just for scientists, but for anyone that was interested in how biology works in space. And for this study, we're given two things. We were given the title and the link for the research papers. So the first step was to automate the process of collecting the information. And now I'd like to introduce Olaf, who will be summarizing our approach to the problem.
So we broke the problem into 4 key steps. First, we displayed the abstracts for each paper in a Google Sheet. Secondly, we categorized the research using keywords. We used AI also to categorize the same studies independently. The keywords are analyzed by program. Then we had AI to do it. And then we used both approaches to compare results to spot research gaps and overlapping trends. So first with the program, we first wrote a script to pull each paper's abstract from PubMed Central. So what the code did, it visited the link, then it found the abstract section on the page. It pasted each abstract section into column C of our Google Sheet. And in this way, we created a centralized searchable database for all 608 abstracts.
So the way the program works is that it uses a function that's called getPMCAbstract. This basically scans the page's HTML, which is just the language that websites use, for the tag section class equals abstract, which is what defines the abstract. It then cleans and formats the text by removing all the HTML, and then it pastes it directly onto our spreadsheet onto section C, which is where all our abstracts are held and organized. Initially, we read some of the papers to identify common topics. We then built a keyword matching system. For example, if a paper mentioned the word biofilm or bacterial, we would label it microbiology. If it mentioned therapy, diagnosis, or patient, then we would label it medical. Papers that didn't match any of those keywords were just labeled as other. The program used a loop to go through each abstract and assign it a category based on keyword matches. These categories were written into column D of our Google Sheet. This process gave us our first view into the types of research that NASA had funded.
We also used AI, specifically the OpenAI GPT model, to read and categorize each abstract. We asked the model to read the abstract in column C and then choose the one best fit category, like neuroscience, genetics, or medical. And we returned that label to be written into column E. Using the OpenAI API, we automated the process. The spreadsheet reads the abstract, sends it to AI with instructions, and then AI returns a single category to us without any further wording. That result gets written into the sheet. And in addition to this, we added a progress message to confirm when all of the papers were processed.
So what did we learn? We now have 2 sets of labels for all 608 abstracts, one from our manual keyword system and the other from the AI model. This gave us a powerful way to compare perspectives. Where did the AI and keyword systems agree, and where did they differ? So some notable patterns that emerged was the physiology category had the most studies with 20 to 26% depending on the method. Secondly, medical came second with 12 to 23%. But neuroscience and psychology were the least represented with just 0.7 and 0.4 respectively. This tells us the mental and cognitive health in space is under-researched, something important to consider for further astronauts and long-term space missions.
We visualized our results using both methods. On one side, we have the keyword-based categorization. On the other, the AI-generated categorization. These visuals made it easy to compare category frequencies and see where the research focus lies. And one pattern that we found was that the AI-based categorization had more categories than when we used the keywords, which shows that there is a difference in which model we take to categorizing our data. Seeing the gap in research regarding psychological studies motivated me to read a sample research paper. This paper showed that stress during pregnancy changes the brain chemistry of offspring in rats. This is a powerful reminder that prenatal care in space isn't just about physical health. It can impact mental development as well. Why this matters. Shorter telomeres, which the study found, are linked to cognitive decline and mental health challenges. So this research gap is more than just academic. It's a question of how we protect future generations in space, especially as we start sending people up into space long term. Our team believes that there needs to be more emphasis on neuroscience and psychological studies. Thank you so much for listening. We hope our knowledge engine helps both scientists and the public better understand the path from cells to space.
How developed is the code? Do you have a working dashboard yet?
Working dashboard for the code?
Yeah.
As of right now, we have all of our code stored in a Google Sheet with so it's in a spreadsheet format, and with 48 hours, we weren't able to develop.
I know it's fast, yeah.
But it's on Google Sheets, and it's very easy to Control F and just search categories, and we have pie charts.
So it's a prototype.
Prototype,
Yeah,
yes,
yeah.
that's correct.
Okay. And so for the keyword versus AI-based search partitioning, the categories, it was hard to, went by quickly. It was hard for me to tell easily how the categories related because there are different categories also. Yes. But presumably when a user is interacting with a database trying to find something they're looking for, conceivably it's not only keyword, you could be interacting with the AI to allow the AI to figure out what the user is really looking for, irrespective of keywords. Have you been thinking about that at all?
We have been thinking about that, but originally we weren't going to do the keyword-based method because we believe that the AI could give us a more like robust method of giving the categories. But as we were coding, we realized that to use the AI, you actually have to pay money. So we only had a certain amount of trials per day that we could do it for free. So we did half of it yesterday, half of it this morning, and then just like moving forward, we think that like we don't want to be constrained by like a for-profit company trying to make money, and so that's why we use the manual keyword-based method.
Okay, sounds good. Do you want to?
Yeah, thanks again. Your project uses a lot of very modern tools, and it seemed very effectively. Has the team already had a lot of experience and practice using these tools, or was a lot of it coming up to speed for the first time?
So, I mean, as high school students, we have a lot of experience using like ChatGPT with like homework assignments and like making the process easier for us. But we actually didn't have any experience with Python at all for this project. And so Friday night, I got all of my friends and colleagues in my room, and we were working on just like self-teaching ourselves Python using like Khan Academy and like YouTube videos. And then yesterday night, we were up pretty late just like trying to get the bugs sorted out. And then we also use AI a little bit just to help like troubleshooting. But most of this is self-taught.
A lot of the screenshots of the code, it didn't look like Python to me. So there's also C programming involved?
It was a mixture, I guess.
Yeah. Where do you, if you were to proceed and take a next step with this objective of categorizing and making more useful this tremendous database, 608 papers, what would be your next step?
So I think for our next step, I just think that like getting the word out there about our research, and as well as making like a dashboard to just like be more interactive for future researchers and the public. Because as of right now, all of our research is shown on a spreadsheet, which it doesn't look very good and it's not very aesthetic. So we want to make it look better, more accessible. And then maybe just like refining how our AI did the search and just more categories to show more gaps in the research.
Have you considered looking at, for example, citation indices that would give an indication of how much attention each of these papers has, or if there are, citation counts is one way, but just to judge the quality and reproducibility of an experiment, there's basically, other than categorizing by keyword, generating some figure of merit for, scientific impact. I'm sure there are databases out there that could also be linked.
Mm-hmm. Yeah, we definitely should consider that moving forward. And I think we had a hard time because we had a hard time looking into the citations because some were formatted with APA and like there's different citation formatting. So it's just hard to like give a numerical value to each citation with our current understanding of how the program works and just coding in general.
Thanks.
Yes.
Have you given thought about who you would approach for funding to kind of answer to, I guess, Justine's question about the dashboard? Because for someone like me to use it, obviously I would have a lot of trouble, but for a scientist, they would have a lot less trouble. But just curious if you thought about who you'd approach for funding.
When it comes to funding like future research or?
Yeah, and fully developing and fleshing out the idea.
I feel like that's a difficult question to answer because, I mean, as of right now, the government is shut down, so we don't know if we can go to NASA for funding. But
good answer.
We might look into going to private companies, like maybe like Blue Origin or other space companies that could help us with getting more funding. Maybe your company could help us out.
There you go. Me and Elon Musk. Thank you.
Yeah, of course.
I'm good, I think.
Any questions from the audience? Yeah.
The code developed, is it the Python or whatever code, is it running on your computer or a Google Colab?
Yeah, so for the question was, where is the code running? Is it running on my computer or is it running through Google? And so what we did was, if you go into Google Sheets, there's like this apps category where you can just like write your own code to like do things. So we just kind of did it there. And then I guess Google did it for us because none of our computers can run this probably. Because I have an iPad, so I don't know if that would do it.
So did you use the OpenAI APIs or you kind of manually?
We used the OpenAI API. Like we went onto their website and they gave us like this like passkey. And so we just copy that into the code to like go through OpenAI. So yeah. Oh yeah, of course. So the question was, did you use OpenAI's API? And the answer is yes, we did. And we used the passkey from their website, which only gave us like 5 attempts per day. So when we saw a bug in our code, it wasted one of our attempts. So we had to like make sure everything was good before we actually run it, because then they're going to make us pay money.
Yeah, from a future perspective, a suggestion, you mentioned about the funding, right? So maybe we can run this AI locally and maybe automate that way to avoid the money being spent on.
Yeah, that's a good approach. And I think we should, as we continue our research, we definitely should look into doing that. Of course. Anything else? All right. Thank you for listening.
Okay, our next team is Quantum Conquerors, and they are addressing the challenge Bloom Watch.
Good morning, esteemed judges and wonderful audience. Today, we, the Quantum Conquerors, are so proud and so honored to be presenting to you our latest innovation, the Flower Finder. Now, you may be curious as to what the Flower Finder is. However, before we get started, we think it's important that you understand what inspired us to actually create our latest invention.
So we primarily found that Earth's vegetation is rapidly changing due to climate stress, land degradation, and pollution, though we do not have an integrated system of monitoring bloom dynamics and implement solutions in low vegetation regions. So you're probably wondering, why does this matter? Well, this matters because blooming is a critical indicator of plant and ecosystem health, pollinator activity, and seasonal cycles. Current monitoring is fragmented and often unrefined, making it difficult to track local bloom timing, intensity, or changes over time. Areas with persistently low vegetation, urban heat islands, degraded soils, contaminated sites, deserts at risk of desertification are especially vulnerable and require targeted interventions. Traditional restoration strategies also often fail in poor soils.
Thankfully, NASA has had great success in advancing our knowledge of vegetation and climate in different regions that allow us to better understand blooming, including low vegetation hotspots. And NASA has accomplished this via NASA satellites like the Landsat, the MODIS, and VIRES, and the NDVI, which is the Normal Difference Vegetation Index, which measures plant greenness. So, which factors impact blooming? Having discussed the key role NASA plays in detecting certain blooming phenomena, let us venture what some of the factors that are impacting blooming are, which are soil hydration, soil pH, air quality, temperature, and access to light, among many other factors.
Unfortunately, some of these factors can be affected by alterations because of climate variances. One of these in particular is soil hydration. So when soil hydration deviates from its average, it can lead to things such as root rot and increased susceptibility to disease in the roots. This could impact the plant's ability to grow as well as other vegetation. Not only this, but poor air quality around plants, such as the increased presence of nitrous oxide or sulfur dioxide, could lead to acid rain, which eventually disrupts the soil pH and therefore disrupts seed germination. And lastly, temperature, while among many other factors, could be excessively high in certain areas, and such high temperatures could lead to the denaturation of enzymes such as rubisco, which help with certain nutrient fixation in the plants, and it could impair the H2O and nutrient absorption in roots with the stomata closure.
So our solution to this is Flower Finder, a dynamic visualization tool powered by NASA vegetation data sets. Number 1, NASA satellite data pinpoints areas of low vegetation. 2, we deploy a robot programmed to navigate to those zones. 3, robot releases mycorrhizal fungi into the soil, naturally helping plants grow. 4, NASA data is used once again to monitor recovery, creating a feedback loop between observation and action.
So, light use efficiency can be described as the amount of dry matter accumulated by plants in relation to the amount of solar radiation absorbed by their leaves. Essentially, this ensures that the light plants absorbed is being used in a favorable proportion to the amount of nutrients they're absorbing. A high amount of light use efficiency signifies that there is high nutrient absorption, good efficient use of light, effective use of soil moisture, great concentration of photosynthesis, and efficient nitrogen fixation, which ties into the next parts of our presentation as well. Not only this, but NASA's technologies such as NASA Worldview can be used to monitor these different conditions. As you can see, figure 1.1 shows the vegetation density distribution in the years June 1st of 2015 and 2020. Through NASA Worldview, we can see that certain areas such as India and Southeast Asia regions had warmer areas as well as greater vegetation there. Not only this, but you can see that in those same areas, there is a greater potential light use efficiency, showing that light use efficiency and vegetation density can be related. Not only this, but you can use NASA's Worldview to monitor other conditions that could possibly affect vegetation growth, such as soil moisture in the years 2015, shown in figure 1.3, the nitrous oxide concentration in the atmosphere in figures 1.5, and the temperature variations in figure 1.6.
So as I mentioned previously about the use of mycorrhizal fungi, you're probably wondering how it works. Mycorrhizal fungus is often called nature's plant boosters because of the way they partner with roots. These fungi extend their roots, the reach of their roots, allowing plants to absorb more water and essential nutrients. That means plants can grow stronger even in poor or stressed soils. When we introduce mycorrhizal fungi into areas with low vegetation, they act almost like a natural fertilizer, accelerating greening and helping new plants establish much faster. They also give plants resilience against challenges like drought, degraded soils, and even climate stress. What makes them especially powerful is that they aren't rare. Different types of mycorrhizal fungi are found almost everywhere on Earth, from tropical rainforests to temperate forests. That makes them a global solution that we can use alongside NASA's data to restore ecosystems anywhere.
The vast networks of mycorrhizal fungi. This visual representation displays the vast networks the mycorrhizal fungi forms in order to exchange nutrients with various plants. All right. You've heard enough about the data, but how about a visual that will assist in solving the issues presented previously? This is the vegetator. Where the duck is located would be where the similar structure to 1.8 would be located. Please note this is not to scale. A combination of the words fungi, where the F comes from, and vegetator is where we got this name. It sprays a solution that carries the fungi spores and fans it out in order to spread the fungi in a location that lacks vegetation, thus promoting plant growth, as my honorable colleague Ananya discussed previously. In addition, it does this while utilizing the rover portion, the bot, in order to maximize the area covered. This is a sample of simple Python forward-moving code that we utilize within the Coding the Robot. The first two lines of the code, we imported specific modules from a library in order to utilize them within the code. The print statement for the motor testing is a startup message that ensures it's functioning properly. We then define various speeds. The next few lines of a code is a function we created in order to get the bot to move forward for 1 second, for example, before stopping. In the final line, which is line 17, the function we defined earlier is run. We built upon this simple code in order to allow the robot to move backwards as well. Imagine what else we could do with this language of Python. These are our resources that we utilize. Thank you so much for your time and your attention. Do you have any questions? Okay. We also have a website presentation which we need to go through.
For more access and for people to actually see what we're trying to work on, we made a website. It's a demo right now. It's not like published to the public or anything, but it's a slight demo from like the amount of time that we had to work on it. So it's not perfect, but it basically shows our demo robot, and basically the information about mycorrhizal fungi, I'm so sorry, and also different types of ways that any person can help improve vegetation in their area, with different types of nonprofits around the world, like one in Africa and then one in Germany. And there's so many other ones that we want to have up there too. So we just have a website for people who want to maybe help out or have more information about vegetation, how to increase it in their area. Thank you.
Did you build that yourself?
I use Squarespace.
Okay, so I have a bunch of questions. Where to start? You mentioned figure 1.6, and you said it's a something along the lines of it being a map of fungi distribution. Can you go back to figure 1.6?
Yes. It's actually a GIF. I have it on here, but it didn't save when I did the PDF. So it just shows the vast networking, how long it is, how big it is, and like it displays how like they exchange with very nutrients with
Yeah, but vast network. What is this a picture of? I mean, is it an agar on a petri dish? Is it in dirt? Is it what kind of?
This is within the dirt.
And how is this picture taken? Do you know?
I'm not sure, but I could look into it too and get back to you.
No, it's okay. How wide of an area is this over?
It didn't specify, but it just said a vast area, and it connects with various plants.
Okay.
I'm sorry.
It's okay. About the data showing the vegetation and flowering across the globe, do you know how that data is generated from the satellites?
So no, the website did not specify as to how the satellites were used to create that, but there were only like certain information. So I imagine it still has to be taken it's taken by the satellites immediately, but not necessarily the information is given at the certain date that it's that is posted there. So like 2015, the data I'm pretty sure is from like later on because there's still current data that's not there even for like this year. So I just know that the data there, it's of the year, but just from a little further on.
Okay. And then, all right, so you guys should look into, read up on hyperspectral imaging, just for the future. And then the robot. Okay, so this is, where did the robot come from? Did you make it?
We created it in a program that all of us are within, the Zebra Explorers program.
Oh, neat.
And I implemented it to represent how we would have a rover and then have that connected where the duck is.
But so, all right, this is, you called it the what did you call that? There's a name for that device.
Oh, the vegetator.
Okay, so is that actually something that would blow spores or how, what is?
So currently, I don't have anything within it because it's.
So if we were to actually do this in the real world, we would probably have a liquid mushroom culture in there that grows the mycelium that is necessary to help with vegetation in areas, and then it would kind of spray out the spores, and then that would help then like the vegetation like to happen.
Okay, that's cool. Maybe someone else has a question before I keep going. Do you guys have questions? Yeah.
Yeah, if I'm not mistaken, there's a commercialization aspect to the challenge that you're asked to respond to. So the area of land that's identified from these satellite maps is pretty big. And undoubtedly, to create a more productive natural environment for plants in any size area, you'd have to consider the cost of scaling up your probably robot army and vegetator. And did you take any first steps towards determining what a realistic cost it would take to make a meaningful upgrade of some of the lands that you identified? And I noticed that you identified mostly non-agricultural lands, so urban spaces, deserts, and so on.
Okay.
So who would want to pay for such a project?
Well, do you want to answer? Okay. Luckily, actually, no, you got it. I lost my train of thought.
Sorry. Well, for our demo, we use something that's on the land, but ideally we do want something like a drone, so that's more able. But we're not allowed to fly drones in Zebra, so we did the next best thing and had a little rover. Cost-wise, we didn't really look into it too much. So yeah, I think that's something that we have to work on going forward. But as of right now, we just have a rover. But we really want to use drones.
Thanks.
And we also picked fungi because it's so easily accessible and you can find it anywhere. And especially mycorrhizal fungi, it's not going to be invasive to any species in where it's grown, as compared to maybe like Plustris austriatus, which is like you have to pick a specific region specific to that mushroom culture. So, and like fungus is just so accessible and affordable, and that's like would help lower the cost, but the creation of it in itself is definitely going to be like expensive because I mean, look at it, and then to make it bigger and then to get all the wiring, it's like a lot.
Thanks.
I want to take it again. You have me again. So this is really neat. I mean, the hardware component is compelling, and at least for some of us, at least Paul and I, we're hardware biased. We like developing and using hardware, and so I appreciate that. But the call is, I think, more centered on the using the NASA data in the form of a user-facing app. So what would that part of it look like?
So our idea for the robot was to like also code it so that it has so that it's like directly connected to what NASA satellites are bringing in, which is why I brought in the figures that I showed earlier from NASA's worldview. Because when I was referencing like the different colors in the picture, so when it's like more red, it would mean that there's like more dense vegetation in certain areas or greater light use efficiency. So in areas that are lighter colored, we would know that if they have drones there, we can directly connect them to like the bot so that it would know that at those times it needs micro Rizzle sprayed in certain fields. And then later on throughout the day, if we see that like, or maybe later on in a couple of months, if we see that the amount of vegetation has grown, we could like not spray as much of the mycorrhizal there and just keep using it in different areas.
Okay, I think that answers my questions. Thank you. Do you have any?
Just have one question, but Paul took my good question. So I was just wondering, is there a way that you could talk about the scalability of what you're working on? Because I would think that you could start small in an urban area and then kind of expand from that. Had you given much thought to that, and how maybe to sell that as an idea?
Could you like repeat your question again?
Sure. And yeah, it's a little convoluted, but what I'm thinking is it's a scalable product. It's a scalable thing. So have you given some thought about how to apply that in a scalable way? Maybe you're starting small and then growing it.
Well, like going back to my previous point, we definitely want to use drones that are more smaller, maybe a little bigger than this, but I think it would be best to use to have them fly in the air instead, so that we don't like ruin the soil or anything like that when we're like spraying mycorrhizal fungi. So, and also like if we had something like that, it would have to be much more bigger, which obviously is more more costly. So I think we would have around the same size or a little bigger, and have like drones spraying mycorrhizal fungi where it's needed. I hope that answers your question. Thank you.
No, it does. Thank you.
Let me ask one more question.
Sure.
I just want to see who had the idea to use a robot in this way to feed back to the environment like that.
I did.
Oh yeah?
Yes. Since we built this previously, I was thinking about how Land Rovers on Mars just like kind of roam around and like have a video representation. But I was thinking in terms of the environment now, how could we implement something like this in order to like spread fungi, for example, in order to promote vegetation.
That's cool. Okay, great. Thank you.
Thank you. Thank you for your time.
Thank you.
Okay. Next, we have Nature's Rangers, also on the Bloom Watch Challenge.
All right, you're going to be able to relax your brain for a few minutes. This is my first hackathon, and what I did was I participated in citizen scientists. My presentation, there are two words just to be familiar with: phenology and spectroscopy. Phenology is the change of a plant or animal's life cycle, like when it leaves, when it flowers, when it dies. And spectroscopy is the study of electromagnetic radiation and its interaction with matter, light generally. Citizen scientist activity I was involved with was Earthwatch. And we went to Acadia National Park And what we wanted to do was set a baseline for the synchronicity of the insect life, the plant life, and the bird migratory patterns. So what we did was we went out in the field and we looked at this was in September, and we looked at the plants to see when they bore fruit. And we counted the fruit on the plants. And then we trapped insects, and we looked at the insects population. And then we put up big nets, and we trapped migratory birds, and we let them go quickly. But what we wanted to do was see who was coming and what they ate, and was it in synchronicity of a normal pattern. So we set a baseline, and it was just to study over time what happens, what changes. And then, so we go out in the field, like I said. So that's a picture of one of us counting berries. There's not many berries in that particular picture, but that's what it was. And there was another group. And this is a national phenological observation society where you have an area that you go into on a periodic basis, and you see what cycle the plant is. Is it blooming? Does it have fruit? And also you'd go out and you'd see, well, my particular thing was milkweed for monarch butterflies. So I look at the different stages of the milkweed, and I look at the different stages of the caterpillar, the pupa, and the butterfly itself, and just make an observation. So these two citizen science activities contribute to a database that we can look at for climate change as it changes over time. So when I looked at the NASA databases, they have an instrument that is attached to an aircraft, and it'll go over an area, and using a spectroscopy, they can tell what particular type of vegetation and what stage the vegetation is at. So my idea is to link this information with the citizen scientists such as Nature's Notebook, Earthwatch, iNaturalist, or Seek, which is a National Geographic type of activity. So this is, like I say, this is just exploratory. It's just like proof of concept, and to be exposed with this information and the information that may be available out there. All right, then I'm just going to give a tip to you guys in high school. When you get a really difficult equation to solve, and they want you to find x, I'll help you find x. Okay. All right. Any questions? I'm glad yes.
So how does this device attached to the plane determine you said the stage of, right? I don't know.
Right. So
is it like using the light waves, like the colors?
Yeah, the term that Justine used earlier, hyperspectral, it uses a multispectral interpretation of what they see. And based on that, they're able to tell what the particular chemical composition of a particular object is. And then from that, they make an inference of what plant it is. The science is a little fuzzy to me right now.
So someone coded this whole thing for this little device to analyze and...
I beg your pardon?
So I'm just curious how that happens, like how this device...
Oh, so it's NASA research, and they've used this over time. And they were just able to put this device on an aircraft to test. I'll give you a link afterwards.
So I'm assuming it kind of dovetails on theirs because they were talking about flowering. So
exactly. They use...
The same device was used for their project, kind of?
They use satellite imagery, which was also in the team description when they have the resources, there's about 15 resources from NASA, and some of them are spectroscopy, and some of them are satellite images, and I'm not sure how they measure with the satellite images. It could be the same technique, but I'm not familiar. But to me, it was just a vast amount of, like we'd go into woods and we'd count berries, and like you get ticks, you know, it's not entirely fun. But this is, and we could also match the data sets that we get, like Nature's Notebook or Earthwatch, and to see if the information pairs up with what they're getting in the satellite image. And if they don't agree, then we'd have to check things a little more carefully.
So did the data match or no? I'm curious.
Excuse me?
Did the data match? Like,
Well, we haven't taken it that far because it's just a proposal to use the data sets that are available in Nature's Notebook and things like that, Earthwatch. So what the basic premise is just that there's citizen scientist activities that are creating databases or information resources, but it can be enlarged greatly by using NASA researchers' resources.
The like counting of the berries and that sort of thing does seem like a very manual effort. Have you given some thought, and again, I know it's in a proposal stage, but have you given some thought about how to utilize technology to reduce that manual effort? Because I'm not a big fan of getting ticks, so I'd prefer to use the technology.
Probably with the AI now, you could take a picture and it'll give you the count. But I haven't given much thought to that. He's trying to come up with a question.
No, I'm just trying. I just want to make sure I understand the. If you could just summarize in like a sentence the. What would an app built based on what you're saying look like? What would the, what would you be presented with as a user? What would you do as a user using an app using this data?
Right, we would have more information available to us.
It would be like graphical representations of that conglomerates the NASA spectroscopy data or something like that. Is that?
Yes, it would be.
Okay.
Yeah, it would be. We would have a more accurate, hopefully a more accurate picture of when particular plants are blooming in a certain area.
Yes. Yeah. Okay. Okay. I thought so.
And based on that, we would we'd know the migratory birds would maybe be fed better, or if they come too early, they wouldn't be fed. Things like that.
Mm-hmm.
Yeah. Okay, thanks.
Thanks. Do you do it? No?
No, I haven't come up with one.
Okay. I think that's it for us.
Okay, thank you. Oh, and I wanted to thank Mike Ciprio for putting this together and the TELSA people for funding it. And thank you for the judges, Ray, Justine, and Paul for coming out and donating their time to this. Thank you.
All right. Hey guys, we skipped Mike's intro. We're the Brookhaven Sharks is the name of the team. Our challenge is Sharks from Space. Yeah, so we're gonna give a quick intro and then pass it around. Who are the Brookhaven Sharks? Meredith Nussbaum is a Long Island High School bioteacher and nature enthusiast. Kyle McGuire is a Long Island High School student and shark enthusiast. And Mike Skelly was also here. I put together the presentation. You can blame me for all the errors. Why did we pick sharks? Well, their sensitivity to environmental changes, pollution, and habitat degradation make them an important indicator of ecosystem health. As apex predators, sharks regulate the balance of marine ecosystems by controlling the populations of prey species. By keeping prey populations in check, sharks prevent ecosystem imbalances that can occur when certain species become overabundant, leading to cascading effects throughout the whole food web. And sharks are heckin' cool. We all agreed on that one. That was really why we picked this. from chlorophyll to sharks is an interesting, why are we doing this? So the objective for our project was to take NASA's data, which included chlorophyll imaging, eddy patterns, and other satellite data of observations of the ocean. The challenge was to create a framework for identifying sharks and predicting their foraging habitats using satellite data. One of the ways that we latched onto very quickly was using the chlorophyll that was obtained by some of the satellite imagery to figure out possible feeding grounds based on the food web. And to talk about the food web, we've got Kyle.
So the bait fish, some of the bait fish are anchovies and sardines, which eat the chlorophyll, but sometimes the sardines will eat the anchovy fry and small fish to have more abundant food sources. And then mackerel, which are predatory fish, will eat the sardines and anchovies, which then seals eat, which are Cape fur seals, which are the most abundant. The seals will also eat symphopods. And then the great white shark will eat the seals and symphopods. And then the fungi, marine fungi, will break everything down.
Perfect. Thanks, Kyle. So, next slide. So one of the big issues we had with this project was just wrangling data. Next slide. So we were able to find 2 data sets that we're looking at. One of them was shark movements over the period of about 2 years off of the coast, southern coast of Africa. We also looked at MODIS data, which is data taken from a pair of satellites that was provided from NASA that measured chlorophyll A, which is an indicator of phytoplankton, which then kind of serves as that base layer of our food web. Next slide. So the 2 images you just saw, there's lots of stuff going on. So we tried to see if we could, using the tools that we found online, using Tagged Animal Movement Explorer TAME, and then NASA Worldview, to just look at like 2 days at a time. So our idea was like, if we can look at just like 1 day of data and then compare them, can we make a prediction on whether or not there are sharks there based on how much chlorophyll is there? Next slide. The problem we had was wrangling the data. So we were working with a CSV file for our shark data, and then we had a netcdf file, which I'm still learning how to code in Python. So it was really hard to pull data. And anytime I was trying to look for what the chlorophyll concentration was, the value I pulled was not a number. So that's kind of where everything ended for us. Next slide. So our limitations in this project is working with 2 different data formats, having some difficulty with accessing the information in the netcdf file. I was able to use some using X-ray and Python to kind of start to parse it out, and then getting not a number as a response back. We did some further digging, and it turns out that the way the chlorophyll concentration was estimated was based on an algorithm that wasn't represented in the file. So that's kind of where things broke down. The big thing for me is, there's tons of data out there that's available, but being able to process it and work with it is proving to be really difficult. So we would love to use this project as a way to develop some sort of tool or any sort of guide to make data manipulation more accessible for high school students and teachers, because the ability to look at real data and do real science would be super rad.
So to summarize the whole thing, what we learned while doing this project is that sharks are cool, as we all knew in advance. Data analysis is really hard, especially when you don't know exactly what's in the data sets that you've been given, and you have to learn a thing to access the thing that you've been given. Professional scientists and researchers know way more than we do. Citizen science is really neat, but it requires a lot more effort than 3 nerds in 2 days. Both the high school student and the high school teacher on our team wish that they knew more accessible tools to dig into the data. But I still want to thank NASA and all the other science agencies for making all of this possible by collecting all of the decades of data that we were able to access and making it available to us and everybody else in the world. All right, we got our references and sources in case you want those. We're also happy to provide this later. And then the last slide is a quick special thanks to the Space Apps Challenge, the Tesla Science Center, and all of our site folks and visitors and viewers like you. Yes. All right. Any questions?
So, like you, I'm not a scientist, so I definitely I feel for you in that regard. One is I definitely want to get a copy of the slideshow because I also love sharks, and I think it's hecka cool too. So thank you. In terms of like the impact of learning this, the foraging of the sharks, I'm personally just a little lost in terms of like, well, what is the impact of that if we were to learn that better? So could you elaborate a little bit on that for me?
Absolutely. So one of the things that we're noticing is that generally speaking, shark populations are on a decline. So if our sharks are not doing well, it's likely our oceans aren't doing well either. And considering that, I know here on Long Island, we have hatcheries and fisheries. It's part of our food source. The ability to have fish and healthy oceans is huge. So sharks are an indicator of how well our oceans are doing.
Thank you. Definitely answers the question. Thank you.
Okay, well, I wanted to applaud all of the teams for making use of Python, which is definitely a heckin' cool language for coding. But for those who are new at it, did you consider asking AI to just write the code for you? Because it's getting very, very good. Of all the things AI can do, coding is something that it's really good at. And for example, describing the databases, the format, what you want to get out of it, in 3 or 4 seconds, the Python code could be there for you to try and run and iterate on that. I guess it's more a question than a comment.
So for the particular data set we were using, the Google Colab tool actually had the AI baked into it. We were able to ask some questions, and it was able to give us some representations of the data that we expected to find. The problem was with the NetCDF data that we were able to get from NASA, we unexpectedly found not a number at almost every location that we found a shark for our shark data. Yep. So actually making use of those data points was very difficult for us. Not being able to break it into a more visible format, I think, is what stymied us. Most of us have done some kind of data transformations, usually in Excel or something like that before, and breaking down this large data set kind of became a roadblock for the project in general.
And maybe I missed it, but could you describe how the animal movement data is generated? Is that part of the NASA program as well?
No, that was found separately. The data from the animal movement was found on another database.
And is it from just observation from ships or
I believe
whatever?
it was radio tracking of the individuals.
Ah, okay, thanks.
It says tagged animal movement explorer, so just a bunch of tagged sharks and such, basically.
Yeah, we used a visualizer to import the data, but it was actually the sharks were radio tagged.
With all your NANs, it might have just been, it was reading everything as in a string and you had to convert it to a float or integer. So I don't know if you, data is a pain.
Yeah, if you want to hang out and talk about it later, that'd be super rad.
Okay. So with the chlorophyll A, so I'm trying to, so something that I don't, so everyone who presented, I think I feel this way about. I like to hear succinctly what the thing is, what the problem is that's solving and how it's being solved. In this case, I think I know what it is. By reading between the lines, but I want to say it and see if it's right, or maybe better yet, I'm going to ask you to say it,
sure,
and then see if it how close it is to my understanding of what's going on. So you just summarize it if you could.
Absolutely. So if we can find what thresholds of chlorophyll are, where we can find sharks, we get an idea of where we can predict sharks to be based off of what how much chlorophyll there is.
Yeah, you should have said that.
Yeah.
Yeah.
That one. Yeah, nailed it.
Okay, that's what I thought. So, so it's the chlorophyll A it's a tracer basically
Yes.
of algal biomass, and the idea is that maybe you could use that to suss out where the sharks are. Now, based on the plots that you're showing, it's not at all clear that there is a correlation, and maybe, but if there's not based on this data, maybe there is, if you look at analyze the data as a function of time, right? So there's a lot to, okay. Okay, so it's a cool idea. I really like the idea. I just wanted to make sure I understood where you were going with it and where you were coming from.
Thank you. I appreciate
I'm
that.
more of a, I prefer dolphins myself, but sharks are cool too.
I mean, we could also track dolphins. And
Okay, that's good.
Any greater predator.
Yeah, any sort of apex predator, absolutely. Great questions. Any questions from the general audience? Cool, great. Thank you so much. You guys have been great. This was so fun. Yeah. Good job, Kyle. You crushed it.
All right, let's have another round of applause for all of our teams. You know, it really is something to have, you know, a group of people spend their whole weekend working on a volunteer project like this. So we are very grateful. NASA's very grateful. The world is very grateful for your contribution. We are going to take a few minutes now. The judges will all confer in the cafeteria. I would ask that everyone please stay here and outside of the cafeteria while we confer. And when we come back, we will have announcements for our top 3 awarded teams. Okay, thank you so much. So I want to again thank everyone who participated this year in Space Apps Brookhaven 2025. Thank you again to our event partners, Zebra Technologies, Suffolk County Community College, U.S. Space Force, from Tesla Science Center at Wardenclyffe. Again, I'm very happy that I think we did a great job this year, and we're very much excited to bring this event to the community and continue to support space science and innovation. So I would like to ask our judges to come up to the stage, and we will be announcing our 2025 Space Apps Brookhaven Local Judging Awards. So please come up to the stage. So I would first like to welcome Ray Schwetz from Jovia Credit Union.
Thank you very much. First of all, I just want to say from all the presentations, I learned so much. I feel a lot smarter now, so thank you. So I get to announce the award for the Zebra Technologies Spirit of Innovation Award. So this is honoring the most innovative project advancing science or technology. So I'd like to give that award to our shark friends.
Yeah, come up on stage. I'll take a photo.
Stand here. Get a picture. All right, cool. Thank you so much. Thanks. Yeah. You did it. All right. Here, Kyle, you should take center.
Yeah.
You found the shark data. That's great. All right. Awesome. Thank you so much.
All right. For the Environmental Impact Award, first of all, I want to echo Ray's words. Very impressive, the hard work that was done in such a short time and how much got accomplished by all the teams. I was pretty impressed, and I also learned a lot myself. So for the Environmental Impact Award, it was a tough call, but we chose, and I'm afraid I don't remember the team's full name, the Quantum Conquerors.
And announcing the Tesla Science Center Designing Tomorrow Award, celebrating the project with the most forward-looking vision of the betterment of, for the betterment of, and the cage is cut off, I'm guessing the world or tomorrow or something? Yeah, humanity, civilization, society, all of those grand things. We award that to those who know.
Thank you. Hey.
All right, thank you again to our judges. Wonderful, wonderful ending awards presentation. So I will say, do refer to the spaceappschallenge.org website. Make sure that your team, all your members of your team have been submitted. You still have until midnight tonight to continue to work on your projects, and one of the teams here will be forwarded to global judging. It may not be one of the teams that won our local awards. It depends upon the work that you do from now until the end of the night and what you submit in the project submission process. So be sure to go over the project submission process section of the website and make sure that everything that you did work-wise is put onto your team submission. All right, that is it. Congratulations. Thank you all, one and all, and we'll hope to see you next year.